and then my head view. Hello, everyone. Good morning. How are you doing today? Please type in the response in the chat box if you can hear me, just to ensure that everyone can hear me and can see my slides. Can everyone hear me? Good morning, good morning, good morning. Beautiful good morning to everybody. Please let me know if you can hear me, please, so I can continue the class. It's 8:02 right now, and I expect that a number of you will be joining in right now. Thank you so much for joining my class. Thank you for joining this class. My name is Gladys Eyidola, and I will be your lecturer for today. Can you can you type you can hear me? I can hear you. I can see my slide. Just leave that. Thank you. So can you see my slides? So can everyone hear me, please? Thank you. I can see a number of you joining. Thank you very much, Alarakwe Bolaji. Thank you. Good morning to everyone. My name is Gladys Eyidola, and I'll be taking you on your SCT 002 this morning. I know a number of you are just coming back from your holidays, but this is going to be a one-hour class. It won't take much of your time. So good morning once again to everyone. My name is Gladys Eyidola, and I'll be taking you on SCT 002, which is Technology and Society. We will get right into it, and we'll start right away. Thank you, Balo Sheriff Dean. So, so technology has been defined by Paul Nightingale in 2014 from a different lens of people. Different people have defined technology. And one of the ways you define technology is how does technology help or impact my society or my immediate environment, right? So from the lens of engineers, you see that engineers would define technology as products that solve problem, as simple as that, products that solve problem. So a number of you might be aspiring engineers. So you think of products that solve your immediate environment, the problems of your immediate environment, such as your roads, the railway, the transport. That's the way engineers would define technology. But a philosopher would say, oh, a technology is a way of seeing the world. It's how philosophers see the world. So you might think of it as a magnifying glass that philosophers use to see the world. Another way to define technology would be from the lens of an innovation manager. So an innovation manager may define technology as the outcome of a problem-solving process, right? An outcome of a problem-solving process. That's for an innovation manager. It's quite interesting because you see lots of innovations coming up, and technologies has been quite instrumental in bringing up innovations these days. If you have any questions as I go along, please just drop in the comment section. I would look at it and respond to it. Thank you. So another way of defining technology from a sociologist's lens would be social and physical environment of complementary devices, systems, institutions, rules, and norms to operate. So sociologists are those, they are experts who work in our society also, and they see technology from the lens of the social and physical environment combined of complementary devices. So you have the social devices, you have the physical devices working hand in hand. Another way to look at that would be maybe the way community members interact. You can say phones also can be one of the complementary devices, because you use your phone to make payments, you use your phone to make calls and the likes. And also, historians would define technology as the outcome of a distributed co-evolutionary process. Technology, from an historian view, would say is an outcome of a distributed co-evolutionary process. Now, you see that from the age long, from the days of when people use machinery, big machineries, for instance, in agriculture, right? You use big machineries, how they, like the plow, like how you use the plows to make ridges in the farm, right? So technology has moved from that to using now synchronized devices where you don't need too much effort, too much time to actually make your to have a result, right? So it's now more of system-based devices you use to get your results. So historians now say that, based on this, the outcome of distributed coevolutionary process. So right now you have both man-made, right? You have both man-made devices working hand in hand with nature as well. From the tech governance person, the person would say technology is the evolving socio-technical process of developing and maintaining solutions to technical problems. You see, you and I know that the phones you used to use, say 10, 15, 20 years ago, that's if phone were ever made then, it's not the same right now. I remember I used to use a BlackBerry, and Blackberries even evolved. You move from Blackberries to the likes, it has evolved. So many things have evolved. So we would go on from there. So now, but for the context of this class, we would define technology as a co-evolving system of solutions, institutions, and worldviews that solves problems and shapes our society. I'll take that again. Technology is a co-evolving system of solutions. What that means is you have multiple devices working together to ensure a solution is brought forward in institutions and worldviews. For instance, the way I see the world may not be the way you see the world, may not be the way a baby sees the world. So all of it combined comes together to solve problems and shapes our society. Remember, the the course we're in is technology and society. So we're looking at how technology functions hand in hand with the society, not optional, not to take out the society, not to take out the technology, but to see how both of them can move hand in hand. Another way to define technology would be technology does not exist in a vacuum. What that means is, for instance, I know how the world is saying, oh, robots are coming, robots are taking over our jobs, but you don't need to evacuate humans so that robots will take over the world. We can work together. For instance, I know in the advanced world, you have robots now doing deliveries, food deliveries, but you don't have to take out the human being who is also doing the delivery, because some people actually find some comfort in having humans also making food deliveries. So technology does not exist in a vacuum. It interacts with people, culture, and environment. It interacts with people from different cultures and in different environments. Now, what is culture? Now, culture is who we are. is who you are as a person, who you are as a student, who you are as, name it, any personality. That's your culture, right? Now, it's also the way we do things. Now, the way you work, the way you live, the way you eat is a culture, and what shapes our identity. So, again, culture is who we are, the way we do things, and what shapes our identity. That's culture. Now, the way people live, communicate, work, think, and interact is linked to and shaped by the tools, platforms, and system they use. Now, the reason for this definition is, if you see the definition, I believe everyone can see my screen, right? Now, if you look at the definition, you would see that both culture and technology can be seen in the definition. It means they are interwoven, right? The way people live, communicate, work, think, and interact, that is culture, is linked to and shaped by the tools, platforms, and systems they use. From this definition, you can pull out another definition of technology, say technologies can be tools, platforms, and systems people use. I will move on to the next slide. Now, these are examples. I'll be moving into examples of how technology coexists with culture in Nigeria, how examples of how technology coexists with culture in Nigeria. I have interesting slides, by the way. So I'd like that you find some viewing pleasure looking at my slides. Thank you. So in communication, you see that social media has enabled the way we communicate. Uh, I believe there are Gen Zs in the house, so you understand this, how technology has improved social media. So you have the likes of Threads, Facebook, LinkedIn, Instagram, helping with the way we communicate with one another, especially with family and friends who are far away, So you have indigenous creators, helping and using YouTube. YouTube is also one of the social media to communicate their ideas. Now, remember we said culture is who we are, right? What we do, how we think. So how is YouTube, which is a technology, helping communicate our ideas? And that is what indigenous creators, by the way, means local creators, local content creators, local uh, local experts who are using their own resources to ensure that communication is aided, right, in our languages. So language is another way we communicate our culture. So an example is Masoyibo. 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 I've actually watched Masoyibo before. So you see one of a celebrity in front of him. I don't know his name, but name of the program is Masoyibo, as you can see from the slides. So this platform is virtual, by the way. It's virtual. It's a virtual Yoruba language show, right? It helps to challenge participants. It's one thing for you to say, "Oh, I can do something," and someone actually test your ability in that. Technology has helped to also ensure that the Yoruba language has been sustained and has not gone into extinction like some other languages. To the left of the slide, you would see an old woman. I intentionally pulled that up to show you that some languages also have gone into extinction because technologies have not helped to make sure that the language is sustained. Right. So the program actually helps to challenge participants to speak exclusively, whether they are saying hello, whether they are saying thank you. You say everything in Yoruba, and when they say that, they get a prize or they get a point, and it goes on and on like that. So it helps to promote cultural preservation, right? It preserves culture. That is another way technology also helps with our culture, preserves culture. I'll move on to the next slide. So, by the way, so you see that technology has helped from language extinction to language communication from the slides. Thank you. So another way technologies coexist with culture in Nigeria is trading, right? Gone are the days where we would pay, although we still do, we still pay in cash, but you see, it's not popular anymore, right? So technology has helped the way we make payments. So the likes of OPay, right? We had somebody, we had the CEO of MoneyPoint come to campus some time back. That's another way technology has helped. It has helped to make payments and has transformed the way we buy. So you can actually sit in the comfort of your house and buy anything. You can buy on Temu, you can buy on Jumia, you can buy from international platforms, right? And then you can also save and you can also sell. I know that on Jumia, you are able to sell your products through an online platform. I don't know how that works, but that's another way technology has helped with our culture, right? It has reduced the rate at which we handle our physical cash, right? Now you see that it has moved from that to OPay to the likes of the POS, right? We use before we use ATM. Oh, we still do use ATMs, right? So we do that. Some people, I think some people till now still goes to pay over the counter, but that's to show that some people still embrace, they still want to retain their culture. That's the reason why they do what they do. So the shift from cash transactions to digital instant transactions is now influenced by speed, convenience, and financial inclusion. Speed, very fast. OPay is very fast. You and I know that. And then it's quite convenient. On the OPay platform, I'm not promoting OPay, but on the OPay platform, you see that you can even pay your bills. You can pay your NEPA bills. You can pay for I think you can also pay for school as well on the OPay platform and MoneyPoint as well. So it has helped with financial inclusion. So there are keywords in all of these slides, by the way. So let's move on. Another way technology coexists with culture is work and knowledge sharing. I'm proud to say that this platform is also a way that technology has helped with culture of learning, especially. Now, this is the OAU TelePresence platform. I'm speaking to you live from the TelePresence room, and you can see that it has helped with how you learn, how I teach you, right? Both lecturers and students are able to teach and learn online beyond physical and geographical locations. Just imagine if after the beautiful holidays, you are called to school, to a large class to come. I'm sure a number of you would not turn up, but the telepresence platform, thanks to OAU, has helped to ease the burden of a large number of you coming down from your different locations to receive lectures. I think we need to commend the OAU, to commend OAU for that. So yeah, work and knowledge sharing. So both work. So you see that there are also platforms that has helped with work. I think there's also what do you call this? There are also platforms. There are work platforms also. I think there's also, yeah, Google Classroom is another place. Is another platform where students also learn, right? But here, this is OAU's type of learning platform. It's customized for students and lecturers to receive and give lectures. So we move on to the next slide. Now, in the globe, we've talked about technologies coexisting with culture in Nigeria. Now we are looking at it on the global platform, on the global scene, on the global landscape. How does technology coexist with culture? So we see socialization, right? Earlier I talked about social media. So we can also go under that umbrella to say socialization has really transformed. Technologies have really transformed socialization globally, right? The way people gather for to participate in social activities. Now, I don't know if a number of you one time have attended weddings, anything, birthdays on social media, on social platforms like Zoom, Skype, right? So one of the ways this has helped is you don't have to travel down. We all know how costly air tickets are, right? Even moving to African countries or Nigerian states, right? It can be very expensive, but that's where technology has helped. Sometimes we really, really, really need to be at some social activities, but we cannot, right? But that's where Skype and Zoom comes in, right? It has helped with the way we attend. It has helped with the way we participate from around the world, right? So that's another way in the global context. Another way in the global context is in health, right? A number of you are fitness gimmicks, right? And we fitness has really helped with a number of things. It has helped with our health, both physical and internal, right? But sometimes it's quite cumbersome when you have to go queue in the hospitals just to receive, sometimes, some people are even burdened to even just to check their BP, just to check their pulse. You have to go and queue. And that's why the picture on the side is there. You see that some people, endless queues, you're there from morning till evening, just to sometimes do a very small, take out do a very small treatment check, right? But nowadays, technology has helped through wearable healthcare devices. You have the Fitbits, right? There's a wristwatch-like device you have to wear that helps you check your pulse, helps you check your heart rate, and the like. Some of it even helps you check your weight. Interesting. So wearable healthcare devices in the healthcare sector, smartwatches, fitness trackers, biosensors, has modernized how people monitor their heart rate, glucose level, and even sleep, right? Checks how many hours you sleep, especially those who have problems with sleep. You can monitor how many hours you sleep, if it's enough, if it's not enough. It helps you to improve or helps you to reduce, which is quite interesting. So instead of just going to check your health imagine going to check the number of hours you sleep in the hospital, and then you go through this queue. It's quite cumbersome, right? But thanks to technology, these tools have provided constant personalized tracking of health levels, giving both doctors and patients real-time information, right? We move on to the next slide. Another way technology has improved in global context is music. A number of you love music. I love music too. But we see that technology has really helped that. And I know, do you remember when we used to use a disk drive and you have to, or what do you call it? You have to roll the cassettes like that. Those are really old days. They're ancient days, I know. But nowadays, we don't have to do that. All you just need to do sometimes is just, especially when you don't know the lyrics of a song, right? You just open Shazam. There's Shazam, which helps to identify the songs that are playing. It will even give you the lyrics, so you don't have to chew your mouth when you need to sing along, right? So, and there's Boom Play as well, right? So I know a number of you, maybe early back in those days, you had one of these this portable ones, right? It was quite, I mean, it was the in thing then, I know. I know a number of you cannot relate, but I had one of those and it was quite interesting. It was like think of it as your iPhone then. So the era has moved from the left-hand side of my slide, which is the big radio, to Boom Plays, to Shazam for music lovers, right? You don't have to guess, oh, what song title? And you have to ask people, ask a number of persons for a song title or lyrics. So now technology has promoted a broader shift in global music consumption. Sometimes it can be difficult to actually know the lyrics of international artists. So Shazam, I think I've used Shazam before, and it's quite interesting, right? Now, altogether, we see that technologies and digital tools have redefined our society to a very large extent, right? More than we can imagine, in ways that often go unnoticed. There are some things our phones usually help us to do, and we don't relate because we just feel a phone can do it all. And that's the reason for the addiction for many of us, many of you addicted to our phones, not because we love, but because of the number of things technologies these days can do, right? Now, the digital transformation should support people, not replace them. What this means is, just like I said earlier about food deliveries, technologies is not replacing humans. No, it shouldn't. It shouldn't replace humans. Rather, it should coexist with humans. It should coexist with our culture. We should actually think up ways where technologies can actually help our culture to grow, to improve, not to eradicate us or our culture. So that's why I have on the slide that says technology is not equal to people, rather, it should be coexisting with people. I'd like to move quickly now. So, managing technology use on our culture. So, how do we manage technology so that it doesn't impact our culture negatively, right? So, over reliance on smartphones. I know a number of you are addicted to your phones because of the number of things your phone can do, which is quite good. It's quite interesting. It actually shows how tech savvy you are. But over reliance, you can't do without putting your phone down for an hour. That's a lot. Rather, why don't you harness your phone positively or impactfully, where you can, excuse me, you can use it for interactions, more impactful interactions, not leading to isolation, right? I know we are in a connected world right now, and a number of you also have, some side gigs you're doing, and you have to use your phone. But you also need to ensure that you maintain face-to-face moments, right? Face-to-face moments are where you see people one-on-one, in person. You don't always, some people would say, "Oh, send me a WhatsApp message." Sometimes some people wants to hear your voice. Some people wants to hear our voices. Some people wants to see us in person, right? Especially our older generations, they want to ensure that the phones are not replacing them. Sometimes when we even go to see our parents, we can't even, just like the picture on the on the right, on the left, you can't put your phone down. Some of our parents just even want to hear us. They want to hear our feelings. They want to have deep conversations with us. So they want to ensure that the gadgets in your hand, the technologies in your hands are not replacing them. Rather, you are using it to ensure that you become a better person, right? Just like the picture on the right. The children, they are using technologies to learn, to interact. Now, you can see that that's why there are two pictures. So on the left is one person facing the phone. On the right is a group of students using the phone together, right, to ensure that they learn together and collaboratively. Now, how do we fix technological culture gaps? We all know from all we have been saying, we know that there are some gaps. We mentioned one in the last slide, which is isolation. All right, that's one gap. Now, how do we fix such a gap, right? Now, the first thing is to foster digital culture. Just like I said before, it's we ensure that we use our gadgets responsibly. Use your technology wisely. Um, Nowadays, security wise, you have to be careful, right? You have to ensure that you are safe, because some of these gadgets can pull the wrong crowd out, can pull the wrong crowd to you, right? So you want to ensure that you use it in the right place, in the right manner, with the right tool, and in the right frame of mind, right? You are not using your phones or your gadgets to do harm or to cause negative harm. No, but to use them wisely. Secondly, digital divide. We understand that technology has created digital divide, but it could be that this technology divide is coming from not using our technologies wisely, right? So we should ensure that we thrive to promote access to technology across locations. You and I know that in some parts of the world, some people don't even know what a phone. Yes, some people don't even know what a phone is. And even those that know what a phone is or have seen what a phone is, they probably haven't seen an Android. I know some people right now uses iPhone, but some people believe that phones are the ones we call palasa. And we know, or we all know, that such phones don't help with learning. For instance, they don't help with knowledge sharing, right? So we should ensure that technologies help with people's culture. For instance, the farmers, we should ensure that they are not only phones. And when I say technologies, I don't mean phones alone. I'm talking about machines, I'm talking about tools, platforms, just like we defined technology the other time, to ensure that it reaches all geographical locations, even in our remote villages, right? We ensure that, so this is also a call to action for students for you, so that as you grow along, one of the things you are hopeful to gain or to give back to the society is to ensure that the digital divide reduces, right, across locations in Nigeria and beyond. Another way to fix the cultural gap, to fix the technological cultural gap, is to support awareness, right? Ensure that people are aware. Now, I know that it might be difficult to ensure that people understand what a phone is. I know it's vague sometimes explaining to another person what your phone can do or what a gadget can do. There are so many gadgets right now, right? And to support awareness, you need to ensure that you're speaking about it, you are using it wisely. I think all three of these points are they're interwoven. When you use your technology wisely, then you would support awareness, then you would support privacy, right? I when we go online, you also ensure that you don't speak harshly to people, you know, especially on the comment box, especially when you're commenting on social media. That's another way to promote privacy, right? You ensure that you are not tearing people down with your words, with your opinions. You ensure that you're also critiquing, you know, with a mind to correct, with a mind to add, with a mind to adjust, right? You're not critiquing negatively, right? And that's a very bad thing to do. So to reiterate, unequal access creates a knowledge gap. When there are different levels of access in different places, then there is a knowledge gap. Um, in I think there's a measurement tool that's called an index, right? That helps to calculate um, knowledge gaps. That helps to calculate knowledge index in Nigeria. But if we were to carry a measurement, if we were to carry a survey around Nigeria, we would see that there are some places where there's quite a knowledge gap. Especially in the northern areas, if we were to just off my head, especially in the northern areas, you see that many places or regions in the northern area are still not keyed into access, right? Are still not keyed into technological access. They still have some challenges getting to that areas. So that's actually another way we can actually help technology to coexist with our culture. Yeah, so to recap all we have been saying for the past 30 minutes, thereabouts. So technology promotes cultural preservation and entertainment, just like we said from Masoyibo, um, on communication. It promotes cultural preservation. I know a number of you don't speak your languages, and here is I would advocate that you try to speak your languages, try to speak your different languages. You know, it also helps to preserve culture. Because you don't know where you'd be tomorrow, and your culture might just your language might just save you, you know. So technology promotes cultural preservation and entertainment, right? You also use technology for entertainment. Secondly, technology brings um, about speed and convenience. We talked about that in the healthcare sector, where technology helps you to check your glucose level, check your sleep levels with speed, right? Using wearable healthcare devices such as fitness trackers, right? So another thing we talked about is technology goes beyond physical and geographical locations, right? That's in terms of in the global context, in terms of communication as well. It helps to connect both the physical and the geographical locations. Another way technology helps is to foster participation. Yeah, foster participation within um, social activities. Sorry about that. Sorry about the pause. Are you still with me? Please let me know in the comment section if you're with me. I can hear you. I can see you. Can you still see my slides? Hello? Can anyone hear me? Can you hear me? Okay, I believe you can hear me. Um, I was on the key takeaways. Technology helps with our culture. So the fifth key takeaway is technology provides real-time information. So you are able to listen to live news on the spot anywhere in the world. That's another way technology helps. Technology also helps to promote diversity, right? So you can have a Yoruba man speaking with an Hausa man online through technologies, right? You can even have collaboration. They can even work together um, through technologies, different technologies. And then lastly, technology can lead to isolation, just like we said in the last slide. It can lead to isolation if not used wisely. It can lead to isolation, right? So moving on to the next slide. I would like to have a little bit of discussion. I think we still have some time on our hands. I like you to think of one technology that has helped you as a student. Describe one technology, choose one technology, and describe how it has shaped your life as a student. I'd like to read one or two comments. I want a little bit of interaction. Um, choose one technology. Just tell us one tech. Just type in the box one technology, and then you describe how it has shaped your life as a student. There are so many tech, not only our phones, right? It could be the fitness tracker if you ever used one. It could be name it, different things, right? I know there's now meta glasses. Some people are able to listen to get information through their glasses right now. So that's another way technology has helped. I also hear that somebody just developed earrings that can actually tell your location anytime. That's another way. That's a good one also. So I'd like to see in the comment section, in the comment box, choose one technology and describe how it has shaped your life as a student. I'll be waiting to read one or two. Let's do that quickly. I'll just give that 2 minutes. In under 5 minutes, we're done. So in 2 minutes, just type one technology that has helped you as a student, that has shaped your life as a student. There are about 316 persons online. So I'd like to hear or to read one or two comments. If you are just joining the class, um, the question we're asking is choose one technology and describe how it shaped your life as a student. choose one technology or think up of the technology that has helped your life as a student so that others can learn also. Remember, the course is Technology and Society. My lecture is on technology and culture, right? So we're looking at how technology coexists with our culture. Our culture could be our language, it could be our tribe, it could be where we live, just like we mentioned from the definition of culture. It could be how we think, where we live, who we are, right? Our identity, how you identify as a man or a woman, right? So, how has it helped you as a person, as a student? Would like to read in the comment box. Let's pick one or two comments and then we're done with the class under, say, 5 minutes. Okay, we have one or two comments. Yes, please, you don't have to raise your hand. Just go ahead and type in the comment box. I would read your, that's Daniel Iniolua. You don't have to raise your hand, just put in the comment box. Okay, you have your answer there already. So Daniel Iniolua says blood pressure machine. It helps to control the rate of blood flow. You see, that's under health, right? Technology has helped with his health. That's another way it has helped with so the culture of healthy living culture. Technology has helped Daniel Iniolua do that. So the BP machine, the blood pressure machine has helped in that regard. Another person says, that's Ojele Yedamilari says, using alarm and digital notes. I can't emphasize that enough. Even as a person, you need you need to use an alarm. I don't know if there are some people that just wakes up naturally. For instance, you want to wake up, say 6 o'clock, and you just leave that to nature to wake you up. I don't know how many people do that. But using an alarm on your phone, that's the reason why we can't do without our phones, yes. But there's a way we can actually use our phones wisely. So another way a phone, helps with our culture is helping us wake up. It helps us to sleep and wake up on time. Monitors, our wake up time. So Damilare uses alarm and digital notes on his phone, and it has helped in managing his time effectively. Honestly, anybody, this works for anybody and everybody, especially in this our age of distraction. Yes, in our age of distraction, it has really, 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 really helped. Is there anybody? Do we want to read one or two more? Anybody? One or two more answers, and we're done. So there's the blood pressure machine. There's the alarm and the digital notes, helping to write quick notes, helping to take down quick information. Yes, it has helped with effective time management. So okay, so we have come to the end of our class. It was quite an interesting class. I enjoyed going through the slides and I enjoyed reading the comment section, the comment box with everybody. And thank you all so much for attending class today. My name again is Gladys Aindola, and we just had the SET 002 class for technology and society. But my class was on technology and culture. Thank you all so much. And I really hope you've learned one or two things, right? I really hope you have learned one or two things. And here you have my contacts. Again, I'm from the African Institute for Science, Policy, and Innovation under the Faculty of Tech. That's my department and faculty. And there is my email address and LinkedIn address for inquiries, for questions. Please feel free to send me or your opinions generally. I'd like to continue the class if ever you want to speak about technology and culture. Thank you all once again, and I really hope you enjoy your weekend ahead and you continue to also enjoy your holidays. I remain Gladys Enyidola. Thank you all so much. Bye for now.
Yes. Good morning. I hope you are here this morning. Okay. So all that I'll just do is if I can go to this now, if I need this. Okay. Good morning. How was your holiday? So you are welcome to this morning class. Uh, don't forget, we were able to, okay, good morning, yeah. So last week, no, it's not last week, it's this week. We were able to finish with electric current. We've been able to do much on series connection, parallel connections, then the total electromotive force, and we try to solve some problems. And at the end of the day, I gave you a question which I asked you to do. I asked you to solve a problem. I say a battery of 1.24. No, I said a generator. Is that what I gave you? Yes. A generator having a total resistance of 2 ohms, deliver 1. So, and I'm sure that you are able to do it, and you are able to give the percentage that I was expecting, because I asked you to calculate the efficiency of the transmission. If you do it correctly, I said it's going to be 95%. That was what we talked about. So this morning, we are moving on to another area in which, when you have a complex electrical circuit, how to solve some of these how to solve for current, for voltage, when you have a complex circuit. And that is why the Kirchhoff rule comes in. The Kirchhoff rule is used to solve complex circuit analysis, if you want to, which cannot be solved by using your Ohm's law, V is equal to IR. And then the rules, they are just two. We are going to make use of 2 rules. The first one is what I call the first rule. The algebraic sum of the currents at any given junction must be equal to 0. The algebraic sum. If you look at, let me give you a very practical example. If you have two batteries connected in opposite direction and they meet at a junction, we can use this rule, what we call a Kirchhoff rule, because I'm going to give you a question that is similar to that. So the sum of the current at that junction is what we call the sum of it must be equal to 0. Or you can say the sum of the current that flows in, that enter at any junction, must be equal to the sum of the current that will be leaving that junction. And then when you sum the current, it will be equal to 0. That's what we are saying. The sum of the current, that is what you have here, the down one here. The sum of the current that enter any junction must be equal to the sum of the current that is leaving the junction. And that is the implication of what we mean by the sum of the current at any given junction or at any given point must be equal to 0. Leaving and entering, when you sum the two together, it must give you 0. The second rule is also very similar, but what we are saying is the sum of, in any given circuit, in any given complex circuit, if you consider the closed circuit, the sum of the potentials, the potential difference, must also be equal to 0. We call it loops. In an Take, for example, as I've said, you are having two batteries connected in opposite directions, and they have a junction. The two batteries were connected at a junction. Let's call it A and B. So I can use what we call the loops rule. And the loops rule is just you assume either clockwise, that is, if the current is flowing clockwise, you use clockwise for all the loops. If you have two loops, take for example, if they are joined at the junction, then the most important thing is that you must consider the same direction for the two different loops. Take, for example, in the first loop, if you use clockwise direction, you are summing the sum of the PD along the clockwise direction. The second loop that you are considering, it must also be clockwise. You cannot use clockwise in one direction and use anti-clockwise in the opposite direction for the second loop. It will not be right. So what is important is at any given loops, the algebraic sum of the potential difference must also be equal to 0. And like what I have here is like you are having an electromotive force, you are having your cell, and you are having your external resistor. If you are having your external resistor, there will be PD across it. If you sum the PD across that your external resistor plus the EMF of the battery that you are using, it must be equal to 0. And you know that is the law of conservation of energy. That's what the second law is based on. The law of conservation, law of energy. You know, energy can, what do you call it? Energy can either be created or if it is created, the sum must be equal to 0. And that is just it. It's conserved. So the same thing is applied to this. I said when the resistance is transverse in the direction of the current, the potential difference across the resistor is minus EF. And that is directly. Take, for example, if you are using clockwise and the direction of the current is the other direction, then the resistor, the EMF or the PD must be equal to negative. Look at that. If the resistor transfers in the direction opposite to the current, can you see now? If it is directly opposite to the current, the potential difference across the resistor must be positive, IR. If a source of EMF is transfers in the direction of the EMF terminal to the battery, then the change in potential must also be equal to change what you have as your EMF. The last rule under the loops theory is that if the trace, on the other hand, is through the source from the positive terminal to the negative terminal, we are talking about a cell now. So from the positive terminal to a negative terminal, then the potential difference must be equal to minus E. The potential difference must be equal to minus E. So please, let me give you your attendance code. Receive your attendance code now. Please get ready. I want to give you your attendance code. JZ, don't forget capital letter, JZLU2. JZLU. JZ, let me type it for you. JZLU2. Did you see it? This is 102, not 104. Are we not supposed to? No, you are not supposed to have one. This is 102. I said J. This is not small letter. What is written here is small letter. So please, is capital letter J Z L U 2. Okay. Yes. That is your, please, it's not JZ. This capital letter as you are having it. That's the first attendance. So let's continue from what we have just said here. So from here now, we can do a lot of works, but I still want you to follow in a situation where you have what you call potential, you are having arrangement. It's also a complex circuit when you have something like a Wheatstone bridge. Can you remember how Wheatstone bridge look like? You have four resistors. You are having four. Two are connected in parallel and the other one in parallel. So, but two are also connected in series. You can still use this kind of complex analysis to solve the for the current and for the EMF across the PD. It depends on how you look at it. You can use the kind of what we just talked about to solve the current. You know what I mean by Wheatstone bridge is a something like you arrange your resistance in a rectangular box. Can you remember a rectangular box in which you have two? In the two edges, they are parallel, and the other two edges, they are series. But don't forget the current that is coming from a cell. I will have drawn, but this cannot draw. That's just it. The current that is coming from a cell is divided into two. Then the one going to the resistance in the upper one, let's say R1, R2, R3, R4. What we are saying is the current that will go through R1 is I1. The current that go through R2 will be R2. So the I must be equal to I1 plus I2. That is the first law of Kirchhoff's rule that we talked about. Then you can also now use, if the current I is flowing through R1 and current I2 is flowing through current R2, you can sum up, either you use clockwise, what is the direction of the current. So if you are moving clockwise, then your I1, because it's in the clockwise direction, times R1, it must be minus, because by the time you move down, the current I2 will be in opposite direction. And because it's in opposite direction, you will have your I2, because it will be I2 minus I2 R2. That's what you will have for the combination. And then you can begin to solve. You do the similar thing for the second loops, and then you can sum the two simultaneously. You can get the value of any unknown resistor among the four, and you can also get the current that is flowing through the circuit. So let me give you another example that will help you. Please, I would like you to draw this. Two cells, you must draw this. Draw it yourself. That is the way to best understand the question. Two cells, 12 volts and 2 ohms. Two cells, you know the cell is having what? Internal resistor. That's why we are having 2 ohms. I said two cells. The first one, 12 volts, 2 ohms. I just 12 volts, 2 ohms, and 6 volts, 4 ohms, connected in opposite direction of, at point A and B. Two cells, 12 volts, 2 ohms, and 6 volts, 4 ohms, connected in opposite direction at point A and B. Full stop. Calculate the current I flowing through the circuit and the terminal PD across A and B. Calculate the current I flowing through the circuit and the terminal PD across A and B. Please, this is very straightforward. How? What you just do, you first draw your two cells. I said they are connected, they are flowing in opposite direction. One is up. You can say 12 volts, 2 ohms is up, and then down one. They will be parallel to each other because they are in opposite direction. But make sure you know a cell, as we describe it, one small line and long line. Long line represent positive and small line represents negative. So you have 12 volts, 2 ohms up, and then down one. By the time you connect the rectangle, you are having 6 volts, 4 ohms. And then they are connected in rectangle. They are in rectangle. And then in between, in the middle of that connection, is a line AB that you have. It's connected. It's just the junction. You have the two wires, the positive of a battery connected to the positive of another battery. The negative of that battery is also connected to the negative of the second battery. And they be at a point A, and the other side at the point B. So you can use this rule. Since they are connected in opposite, they both currents are flowing in the same direction, so they are opposite. For if you are using the first rule, the second rule, the sum of EMF or the sum of PD must be equal to 0. So what we are saying is, I must say, okay, the effective EMF or the effective PD across the two cells will just be E1 minus E2. Don't forget, when we were talking the other time, we said when you connect a cell parallel, when they are in series. When they are in series, yes, we talk about series first. We said you had the EMF. Can you remember? We had the EMF. But when you connect them in opposite, they are parallel. What you say, it will just seems as if it's only one cell that is working. But they will have, each of them will have internal resistance. And that is why we are finding 1 over small r plus 1 over second small r plus 1 over, depending on the number, will be equal to 1 over small r effective. And that is how we calculate. We said the internal resistance will be reduced and your battery will work more effectively if you have so many cells connected in parallel. That was what we said the other time. But in this case, we are looking at the battery connected in opposite direction. If it is in opposite direction, the positive is in this direction, the positive in another direction. They are not, the current is not the same. What I'm saying is the current is flowing in opposite direction. So it means the effective one will just be the difference. So from our E now, we can say E is equal to 12 minus 6. That will be my effective voltage that you will have. I said, since the battery are connected in opposite to each other, the net EMF is given by E is equal to E1 minus E2. And if you do that, you will have 12 minus 6, and then the effective EMF will be what? Will be 6 volts. But don't forget to calculate the current, because that's the first question. The first question says calculate the current. Calculate the current. To calculate the current, what you do is you know that, as I've said, when we were talking about parallel connection, we said the 1 all over will give you what we call this effective resistance. But in this case, to get the effective resistance, because they are just connected in opposite direction. So what I will just do is my R will still be R1 plus R2. And if it is that, then I will have 2 plus 4. And if I have 2 plus 4, my R is equal to 6. So from there now, if I want to calculate the current, my current will just be equal to E, the effective EMF, which is the difference, E1 minus E2, all over the effective internal resistance, which will be equal to R1 plus R2. So we have 6 all over 6. And that will give me what? That will give me 1. So it will be 1 ampere. That is what we are going to have. That will be 1 ampere. So if I want to connect, I want to calculate the PD across along AB now, because they are connected at 2 junctions, A and B. A and B. A and B. Since they are connected at the 2 junction, then for me to get the EMF using the second law of our Kirchhoff rule, it will be E1 minus I times R1. Can you see now? E1 minus I R1. And if I do that, my E1 is 12. 12 minus 1 times 2. Don't forget, 1 times 2. If you do that, that will be 12 minus 2. And then you will have your PD, the terminal potential across AB, will just be 10. If you do the same thing for the second E2, you are still going to have the same. But because of the law now, you know, we use minus. We said E1 minus IR1. That is what gives us, because if you use your, as I've said, we are using clockwise. If we are using clockwise, that's why that one is minus. So if you are using the same clockwise for the second loop under the down one, you will have E2, my VAB, which is the same thing, just to cross check what we have done along for this second AB, we just be equal to VAB will be equal to E2 plus I times R2. I times R2. So if you do that one correctly, I times R2, don't forget your I is 1, your R2 is 4. That will be 4. And your E2 is 6. So you will have 6 plus 1 times 4. And that is 4. 4 plus 6 will also give you 10. Can you see now that law holds? So if you connect along AB, the V along AB with R1, E1 and R1, then you will have 10 volts. If you connect across AB with your E2, R2, then it will still be 10 volts. So that makes it the right answer. The answer is 10. That is the correct one. So please let me give you the second, your second code, attendant code. I want you to write it down. Your second attendant code is capital letter Z, Z, M, Y, 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 R. Z, M, Y, Y, R. That is your second attendant code. So from there, you have gotten your VAB, and our VAB is 10. The voltage across AB, the voltage across AB, or you can say the terminal PD across AB is 10, and the current is 1. Let me give you another one. This one, it is directly applicable to the Kirchhoff rule. Calculate 1. You can write 1. Calculate 1. The first one, the current in the circuit whose cell E1 is equal to 12 volts and E2 is equal to 24 volts, flowing in opposite direction, whose external resistance R1 is equal to 4 volts, and R2 equals 6 volts, connected in the opposite direction. Don't forget, it looked like very similar to the other one. But you can see now that instead of having your internal resistance here, it was this one is now external. This one is now external. I said calculate 1. The current in the circuit whose cell E1 is equal to 12 volts and E2 is equal to 24 volts, flowing in the opposite direction, whose external resistance R1, capital R1, not small r now, not small r, not small r now. Capital R1 equals 4 volts and R2 equals 6 volts, connected in opposite direction. 2, that is still under the same question. I said question 1, I've mentioned it. 2, the power delivered to each resistor. We are to calculate A, the current. The second one, the power delivered to each resistor. 3, also find the power supply by the 24 volts. Also find the power supply by 24 volts. Have you gotten that? Please, this man, Emmanuel, what you have, the code is wrong. What you wrote down is wrong. It's not, there's no, the code I wrote down for you, there is no 2. It is R. Please, it is R. Has anyone been able to write the question down? The question I dictated. I want you to post it. Post it. Let me see it. Let me see the question you have written. Calculate A, or you can say 1. The current. Yes. The current in the circuit whose cell E1, capital E1. Yes, I want you to write it down. I want to see when those who are writing, so that you, like what Freedom Oluwafisayo, the one you wrote for the first question. I want someone to write it. I want to see it too. I'm also monitoring you. So I want to see someone that will write the question. Write it for me. I want to see, so that I want to know whether you get what I'm trying to say. I said calculate A, or 1, the current in the circuit whose cell E1 is equal to 12 volts and E2 is equal to 24 volts, flowing in opposite direction, whose external resistance R1 is 4 volts and R2 equals 6 volts, connected in opposite direction. 2, the power delivered. This is a continuation. They say calculate the power delivered to each of the resistors. 3, also find the power supply by the 24 volt by the 24 volt battery. And I said, once you have been able to write the question, then you should be able to solve the problem. I want someone to draw it. Draw what we have just said. It's a rectangle. Current. Unfortunately, I don't have what to draw here. We have to draw the current. If you have a means of drawing, it must be a rectangle. R1, yes. You have not finished the question. This is just the A part. B, write the B part. I said for the B part, calculate the power delivered to each resistor. 3, find the power supply by the 24 volts. So you have just written half of the question. R1, yes. Sir, is the first question we solved. Why did we subtract it's because of the direction. I said it. Look at it. The second one, because they are flowing in opposite direction. That's why we didn't use minus. We use plus. Yes, in opposite direction of this. Then find the power. This is C part. Owolabi Tajudeen Adesina. That is B part. I mean C part. I want you to write the B part. The power delivered to each resistor. That's the B. That's the high. The power delivered to each resistor. C now. I mean the third question now will now be the power. Find the power supply by 24 volts. By the 24 volt. That is, and as I've said, you draw the diagram. If you draw very well, you are having the force just similar to what we had in the first question. But please, there is no, we don't put the internal resistance here. The internal resistance is not here. What we just E1, then the external resistor will now serve like your will now serve like your junction where you put A and B. The A will now be 6 ohms, and B, the junction where you join, will now be for 6 ohms and 4 ohms in the B part. So you will now have a rectangle where you have your first E1 up 12 volts connected to is R1, which is your 2 ohm by your right, and is 4 ohms by your right, and 6 ohm by your left. By your left, and then connected to the second battery E2 down, which will be 24 volt. All these must be in rectangle. If you like, you can label the rectangle A, B, A up, B down, C to your right, then D to your hop that join the circuit. So you label the rectangle A, B, C, D. Don't forget, AB, you are having your resistor R2. CD, you are having your resistor R1, which is 4 ohms. So you are now having your E1 up, which is in the same direction. You are in opposite direction to E2. So you are connecting them in opposite direction. And now say using Kirchhoff rule, no junction is in this single loop circuit. The current is the same. The current that flow through is just a single current. So if you now connect here, if you now connect A to B, A to D, yes, your A to B will represent a potential change of plus E1. Please take note now. I said if you must first of all label, that will make it very right. Rectangle, A up, down of A, you are having B. But in between A and B, you are having R2, your resistor R2, which is R2 equals 6 ohms. Then between B and C, you are having your E2, which is 24 volts. And between C and D, you are having your R1, which is your 4 ohms. And between A and D, you are having your E1, which is 12 volts. So if you look at that, apply clockwise rule, your clockwise rule. If you apply, you know what clockwise is. If you are flowing, if you are assuming that current is flowing from the terminal from D down, because if it's flowing down from D, then you can see now if I use clockwise, my my E1 will be positive because it's flowing in the direction of the normal. The current, if you look at your cell, the longer line is in the direction of my clockwise. So because of that, that was why it's positive. So I said from A to D, it will represent your potential change of plus E1. D to C, look at your D to C now. D to C, you can see that it's still flowing in the direction. You can see D to C. D to C now. Because of that, it will represent the potential difference of minus I, the current that is flowing now, because it's only one loop, I R2 minus R2. Now look at C to D now. Your C to D. Your C to D. No, your C to B. C to B. Look at it. A to D, D to C, C to B. Your C to B will represent a potential change of minus E2. And your B to A will represent minus IR2. You can see the way we have done it now. A, B, C, the edge of your triangle. We are now saying that from A to D will be positive E1. That is the resultant potential change. From D to C, you can see that that one is anti. So because it's anti, it will be minus IR2. From C to B now, still following that, because it's in the same direction, clockwise, that we are following. So you can see that it will be minus E2. And from B to A now, you know, we are starting from A. It must be a closed loop. It must be a closed loop. So it will go back to A. And if you do that correctly, you are going to have minus IR2. So using the summation that we have done the other time, the summation that for the second rule, Kirchhoff rule, summation of E plus IR must be equal to 0 at any given junction. So it will imply that I minus IR1 plus R2, bracket close, must be equal to E2 minus E1. Minus E1. So my I will just be equal to E1 minus E2 all over R1 plus R2. Please, because of minus, that's why we rearrange. Don't forget, we said you will have plus E1 minus E2 minus, if you want to use that summation of E plus IR must be equal to 0. If I want to sum all the four that we have mentioned up, it will be plus E1 minus E2 minus IR1 minus IR4 must be equal to 0. And if that rule, you can rearrange now. Collect the like terms together and collect the like terms together. So if you bring minus IR1 minus IR2, you will just have minus I bracket R1 plus R2 must be equal to E2 minus E1. We have taken it to the other side. So my E2 that is negative in this side will become positive. That's why it's E2 minus E1. So rearrange to make your I. Don't forget we have minus I. So it will now change where you have your E2 minus E1. It will, by the time you rearrange, what will you have? It will now be E1 minus E2 is equal to, so from here you can have I is equal to E1 minus E2 all over R1 plus R2. And if you do that correctly, it will be 12 minus 24 all over 4 plus 6. 6 plus 4. And if you do that correctly, that will be 12 all over 10. And that will be minus 1.2 ampere. Please, that minus is just indicating the direction. And truly, if you look at it, my E1 is 12 volts. My E2 will be 24. So that definitely the current must flow from E2 to E1. But when we were doing it, we said the current, is our assumption. That is why we just assume that we want to use clockwise. Because we use that clockwise, that is why the current is minus. If you use anti-clockwise now, if you use anti-clockwise, you will have positive. And it is still the same. You will still have I is equal to 1.2. So that minus, I'm just bringing the notation, that notation minus that you have is just an indication to show that the current is in the opposite direction. The current is flowing in the opposite direction. That is, the current is flowing from 24, not from 12. Because the effective, if you find the effective, 12 and 24 is more than 12. Electromotive force, we said we call it electromotive force. So the current must flow from higher potential to the lower potential. So that is why it's minus 1.2. So by the time you do it, it's use the anti-clockwise direction, you will still have plus. You will have I is equal to 24. I mean 1 plus 1.2. So the negative sign, write this down. I said the negative sign indicates that the direction of the current is in opposite as assumed direction, opposite of the assumed direction. It's our own that we assume. We assume that the current is flowing from 12, not from 24. That's why you are having minus 1.2. But if you assume that the current is flowing from 24, you will still have positive, which is the right direction. So, big question now, you are asked to calculate the power. For me to calculate the power, P1 will be equal to what? Don't forget, power is what? We have done that. We said power is IV. And we said in case if the current is not given, you have V squared over R. Or if the voltage is not given, we have I squared R. Can you remember all those equations that we wrote? So we are now saying that for me to get the power, if I use P1, my P1 will just be equal to I squared R1. Don't forget the same current is flowing because there is no junction. We don't have junction. So it's only the one current that will be flowing, 1.2. So you have 1.2 squared times 4. That is the current that will flow through P1. That means through, if you are considering E1, the PD, the power that will flow from P1, from E1. If I'm considering the power that will flow from P2, it will be I squared, the same current that is flowing, times R2. And that will be 1.2 squared times 6 ohms. Don't forget, R2 is 6 ohms. By the time you do that one, you will have 8.04 watts. 8.64 watts. The first one, P1, will be 5.76 watts. So you must calculate the two because they are two different. They are two different. He said calculate the PD across what? Across each resistor. So we have calculated P1, which is 5.76, and the P2, 8.64. Then he says since the total power supplied to the resistor will be what? P1 plus P2. You must add them together. And if you add them together, it will be 14.4. Just 5.6 times 76 plus 8.64. If you add them together, you will have that 14.4 watts. The third question under it, the power supply by the 24 volts. Very easy. As I've said, I said power is IV. So you just say power is what? I E2. Your E2 is now 44 and 24 volts. So you just multiply 1.2 times 24 watts. By the time you do that, you have 28.8 watts. Let me give you the code, the second code. The second code, the third code. The third code for is E2 PET. E2 PET. That is the second code. Yeah. Yes. I could see that you people are getting it. So please, that is the end of the class. I'm having another class now, so I need to just go. Yeah, not B.O. Emmanuel Kola. Kolapo is not B. Ah, thank God you have deleted it. It's E to P. P E T. Yes. Yes. Formula of mercy, you have gotten it. Yes, like that. Thank you very much. Have a nice day. So, have a nice day. So, yes, I finished. So streaming the work. So you can see their response.